Hello students, welcome to IP Study video lectures. Today we are going to study chapter 1 of grade 8, which is a square and a cube. In this chapter, we'll be covering what are square numbers, what are cubes, what are square roots, and what are cube roots. And apart from these four, we'll cover different methods to find squares, cubes, square roots, and cube roots. So, moving to our very first topic, which is square numbers. So students, square numbers are numbers we get when we multiply the number by itself. For example, if we multiply 2 by 2, we get 4. So 4 is a square number. Likewise, we can say when we multiply 3 by 3, we get 9. So 9 is a square number. So basically, when we multiply a number by itself, the resultant number is a square number. Now there is a special term called perfect square. What is a perfect square? So a perfect square is a number that can be represented in the form of square. For example, if we say 25, 25 can be written as 5 into 5 as 5 square. In the same way, we can write 36 as 6 cross 6, which is 6 square. So any number that can be represented of a square of any number is called a perfect square. If we consider a number 5, so can we write 5 as a multiplication of two numbers? No, we cannot. So 5 is not a perfect square. Now moving to the next topic, we have relationship between area and perfect squares. So students, you know, area of a square and perfect squares are closely related. Whenever we talk about area of a square, we simply look for the formula of area of a square. So formula says side into side, which is side square. So somehow these two are closely related. When we look at this table, we take the side length as 1 unit. We get the area as 1 cross 1, which is nothing but 1 square. Now for side of unit 2 lengths, we get 2 cross 2, which is 4. 4 is nothing but 2 square. So area of a square and perfect squares are definitely related. Moving to the example 1, here we need to find the area of a square with the given side. So what do we need to do here? We simply, either we can use the formula or we can take the square of the given number. In this case, the side is 26 centimeter. So to get the area of the square, we simply take the square of 26. So square of 26 is 676. So area of a square will be 676 centimeter square. Now moving to the special cases where we will learn how to get square of certain numbers using some smart tricks. For example, firstly we take a number that ends with 5. Firstly, if we take the number 25, so how will we find the square of 25? To find the square of 25, we need to divide the square number in two parts. So there will be two parts. So most part will contain 25. This is permanent. A number that ends with 5 always have 25 in its square value. So the rightmost part is permanent and we need to find the leftmost part. So for this part, firstly, we look at the number 25. So we need to see the number which comes right before 5. In this case, it is 2. Now we take the number that comes right after 2. In this case, it is 3. So we take the number and we multiply these two numbers. So 2 cross 3 is 6. So this is the number we were looking for. So our square number will be 625. Let's take another example to understand this. For example, if we take 35, so there will be two parts. So rightmost part will be 25 and the leftmost part will be 3 cross 4. Like firstly we'll consider the number that comes right before 5. In this case it is 3, and next we take the number that comes right after 3, which is 4. So now we take the multiplication of these two, which will be 12. So 25 is the square of 35. So this is the trick we use to get the square of numbers that end with 5. Now coming to the second trick, we have the numbers that come near 100. So we need to find the square of numbers that are near 100. There are two cases. The first case is when the number is less than 100. So what we need to do here? Firstly, we consider the number. In this case, we have the number is 96. So our first step will be to take the difference of 96 and 100. So 96 and 100. Its difference will be 4. So consider this difference as our main element. Now what we need to do here? Now we take the square of 4, which is 16. Now likewise we studied in our previous trick, there will be two parts in this as well. So first rightmost part will be fixed. This will be 16. Now the leftmost part will be taking the difference from the number and the difference value we got. So in this case the number is 96 and the difference we got is 4. So taking the difference will result in 92, which we write right here. So the square of number 96 will be 9216. There is a second case when the number is greater than 100. So when the number was less than 100, we took difference, then we took the difference of the original number and the obtained difference. So in this case, when the number is greater than 100, firstly we take the difference, and in the next part we add that difference to the original number. For example, we have 107 here. So to take the square of 107, firstly we take the difference from 100. So in this case will be 7. Now what we need to do here, we need to add 107 and 7, which will be 114. Now for the rightmost part, we have to take the square of 7, which is 49. So the square of 107 will be 11449. Moving to the next topic of our chapter is the properties of square numbers. So let's have a look what properties we are going to cover under this chapter. So our first property is unit digit rule. What is unit digit? Whenever we take a number, the rightmost digit is called the unit digit. For example, if we say a number like 41, so 1 is the unit digit in this case. And if we say 449, so 9 is the unit digit. So let's see some patterns when we take the square of numbers and how this unit digit patterns come into process. So when we take a number 1 and take its square, we get 1. When we take the number 2, we get its square as 4. Similarly, we can take number 10 and its square will be 100. So let's have a look like how these numbers are related. We can see there are certain numbers written down here. So square of 1 results in 1 and square of 9 results as unit digit 1. In the same way, square of 2 results in 4 and square of 8 results as unit digit 4. So somehow these numbers, we need to look at the numbers that give same unit digit. So what we learned from this table, here we can say that number 1 and 9 have same unit digit when we take the square of the number. Likewise, the number 2 and 8 have same unit digit when we take a square. 3 and 7, 4 and 6 have same unit digits whenever we take a square of any number that ends with same digits. Now there are two cases when the unit digit carries the same value. When we take any number that ends with 5, the unit digit of the square value is always 5, and the same rule applies for 0 as well. Now coming to the next subtopic, we have odd and even square numbers. So it's quite simple. Whenever we take any odd number, when we take its square, we always get an odd value. For example, if we take 5 and we look for its square value, we multiply by 5 into 5. So result is 25. In this case, the unit digit is 5, so it is obviously an odd value. The same rule applies for even value. Whenever we take an even value, the square of even value will be an even value. Now look at the numbers that contain 0 at its end. For example, if we say the square of 10. So square of 10 will be 10 cross 10, which is 100. So we can see that the number 10 contains 1 0 and its square 100 contains 2 zeros. In the same way, if we look at 100, 100 contains 2 zeros and its square 10,000 contains 4 zeros. So what do we get here? We can see that whenever we take a square of a number that ends with 0, its square value always gets 0 doubled. So for example, if the number has 1 0, in its square we have 2 zeros. If the number has 2 0, in its square we have 4 zeros. So basically, when we have a number that has n zeros at its end, the square value will have 2 n zeros at its end. Now moving to the next topic, that is difference between square and consecutive numbers. So in this case, we take two numbers. We take two consecutive numbers. For example, if we take 5 and 6, when we take difference of a square of these two numbers, we get, so square of 6 and square of 5, we take its difference, we get 36 minus 25, which is 11. So how do we generalize this thing? Let's understand this using this example given right in front of us. So we can see there are two numbers given to us, 2 and 1. What we need to do here, we need to take squares of these numbers and look for its difference. So 2 square is 4 and 1 square is 1. So its difference is 3. How do we get this difference without using squares? To get the difference without using squares, we simply need to add these numbers. Like we have 2 and 1, to get the difference between its squares, we simply add these two numbers. 2 plus 1 is 3, which is the difference between squares of these numbers. For example, if we had 26 and 25, to get the difference between squares of these numbers, now we need to add them. So 26 plus 25 is equal to 51. So 51 is the difference between squares of these numbers. Now moving to the next subtopic, we have non-perfect squares between consecutive square numbers. So there are always perfect squares and non-perfect squares in between numbers. Whenever we write numbers, for example, if we say 1, 2, 3, 4, 5, we can see 4 is the only perfect square, 1 is a perfect square, 2 and 3 and 5 are not perfect squares. So how do we find these numbers? Whenever we take two consecutive square numbers, how do we find how many non-perfect squares are there between those two numbers? So let's have a look for the table. In this table, we have two numbers, 1 square and 2 square. So 1 square is 1 and 2 square is 4. So how many non-perfect square numbers are there in between these two numbers? We can say there is 2 and there is 3. It's quite easy to find whenever we have some small values, but it becomes really difficult when we deal with larger values. For example, if we say, if we have 7 and 8, so 7 square is 49 and 8 square is 64. So how many non-perfect squares between these two numbers? To get the non-perfect squares between these two numbers, we use formula 2n, where n is the first number in the perfect squares group. In this case, it is 7. So how many non-perfect squares will be there? There will be 2 into 7, which is 14. So there are 14 non-perfect square numbers between squares of 7 and 8. So our next topic is, how do we understand whether the given number is a perfect square or not? So there is a method called prime factorization, and we are going to use this method to understand how do we differentiate whether a number is a perfect square or not. So prime factorization is a method in which we look for prime factors of a number. For example, if we have 6. So what are prime factors of 6? So whenever we divide this number with 2, we get 3. Whenever 3 is divided, we get 1. So prime factors of 6 are 2 and 3. Now look at the number 6. How do we say that 6 is a perfect square or not? So whenever a number has a pair of its prime factors, that number is a perfect square. For example, if we say 4, 4 has 2 cross 2. That means 2 square. So there is a pair for 4. So 4 is a perfect square. Now if we say 16, we can write 16 as 4 cross 4. This is also a pair. So 16 is a perfect square. Now let's take an example where we say like 15. We can write 15 as 3 into 5. So we can say there is only one digit which is 3 and there is another digit which is single in terms like 5. There is no pair, like we don't have 3 cross 3 or 5 cross 5. That means if we don't have any pair of its prime factors, that number is not a perfect square. So let's understand this topic using an example. In this example, we have number 98 and we need to find whether the number is a perfect square or not. So let's have a look on the prime factors of the number 98. Here 98 can be written as 2 cross 7 cross 7. So we can see only number 7 is in the pair and number 2 is left unpaired. So there is no pair for number 2. So we can say that number 98 is not a perfect square because in its prime factors, number 2 has no pair. So moving to the next subtopic, we have Pythagorean triplets. So in our previous grades, we have studied a theorem called Pythagorean theorem, which stated that the sum of squares of two smaller legs is same as the square of the larger side of the triangle. So in the same way, Pythagorean triplets are the numbers which represent the same property. So in particular, we consider three numbers which represent Pythagorean theorem. Like we have three numbers. For example, if we have A, B and C, and whenever we take sum of squares of any two numbers, that should be same as the square of the third number, and third number should be the largest one. So let's understand this using this example. Now there is an important note. Whenever we have a number like 2m, so its Pythagorean triplets will be 2m, m square minus 1 and m square plus 1. This will be a Pythagorean triplet. For any number, we can write like this. So let's understand this example 7. In this example 7, we have been given the side of a right angle triangle which is 14 centimeter, and we need to find the Pythagorean triplets using this. So we can consider 14 as 2m. This results in m equal to 7. Now we can simply use the Pythagorean triplets given right here. We can use that the first term is 2m, which is 14, and second term is m square minus 1, which is 7 square minus 1. This will be 48, and the third one was m square plus 1, which is 49 plus 1, that will be 50. So Pythagorean triplet is 14, 48 and 50. This is how we use Pythagorean triplets to form numbers, to make use of square numbers to form Pythagorean triplets. Let's understand the different patterns we are going to cover under this chapter under the name of square numbers. So there is first pattern, visual representation of perfect squares. What is visual representation of perfect squares? So in our previous grades, we have studied that we can write different square numbers in terms of dots representing the square numbers. Likewise, we can see 1 can be represented as 1 dot, 2 square can be represented at 4 dots, 3 square similarly 9, 4 square 16 and 5 square is 25. We can see all these dots form a special shape which is a square. So the visual representation represents that a number can be represented in the form of a square of dots where each side represents the number for which the square number is being represented. Like we can see, for example, if we take a number 3, we can see its side contains 3 dots. And for example, if we take number 4, its side contains 4 dots. So whenever we take any shape represented in the form of dots, that side of the dots represent a number for which we are taking the square of the number. Now coming to the next subtopic, we have sum of consecutive odd numbers. So square numbers represent a very special relation with odd numbers. Whenever we add consecutive odd numbers, we get a square number. For example, if we add 1 and 3, we get 4, which is 2 square. Now if we add 1 plus 3 plus 5, this is 9. This is same as 3 square. So the number of times we add odd integers, we get a square number, and the number of times we add, so that number represents for which we are taking a square number. So the sum of first n consecutive odd numbers is equal to n square. Like we can take another example. If we add 1, 3, 5 and 7, we get 16, which is square of 4. So the number of times we add consecutive odd numbers is the number for which we are taking a square. Now looking at the special pattern of squares, like the number that ends with 1. So whenever we take 1 square, that is 1. Whenever we take 11 square, that will be 1, 2, 1. Similarly, when we take a square of 1, 1, 1, we get 1, 2, 3, 2, 1. So there is a special pattern. Whenever we take a number like that ends with 1, we get to see palindrome numbers. So palindrome number is a number that can be read same, be it forward or backward. So our next topic is square roots. So far we have studied square numbers. So in square numbers, we multiplied the numbers by itself to get the square numbers. But in square roots, it's the reverse process of squaring numbers. So square root of a number is a number that was multiplied by itself to get the square of that number. For example, if we say we have 25. 25 is 5 cross 5. So 25 has a square root 5. In the same way, if we write 36 as 6 cross 6, so square root of 36 is 6. And this can be represented as a radical sign, which is this one. And whenever we write, suppose if we write this, that means square root of 25 will be 5. So students, whenever we take a number and we look for its square root, we always get two numbers. For example, if we take a number like 64, so square root of 64 will be plus minus 8. What does it mean? It means the number can be positive 8 or negative 8. But in this grade, we'll be covering only positive numbers which represent the principal square root. We are ignoring negative roots of the number. We'll study these negative roots in the later grades. So let's have some of the square roots given to us. So let's take a number 16. What is its square root? Its square root is 4. And how do we get this square root? We just look for the number that is being multiplied to itself, and that number is the square root of the given number. So there are different methods to find the square roots of a number. So our first method is repeated subtraction method. In this method, what we do here is we subtract consecutive odd numbers to get the number 0. So number of steps we take in this process will be the square root of the number. So let's understand this concept using this example. For example, 8, we have a number 81. We need to find the square root of 81. So what we need to do here, we need to keep on subtracting odd integers until we reach the number 0. So firstly, we'll start it with 1. So 81 minus 1 will be 80. That will be our first step. In second step, we subtracted 3, then 5, then 7. Likewise, at the end of step 9, we subtracted 17 minus 17, which is 0. So once we get the 0, we stop and count the number of steps we performed in this process. So in this case, we performed 9 steps. So square root of 81 will be 9. Moving to the second method of finding square roots, the second method is prime factorization method. So in prime factorization method, we take a number and we look for its prime factors, and once we pair them, so we count one pair as 1. For example, if we take any smaller number, for example, if we take 16. So what are its prime factors? That are 2 cross 2 cross 2 cross 2. Now look for pairs. So 2 cross 2 is a pair and 2 cross 2 is a pair. So there are 2 pairs of 2. For square root, we count 2 pairs as 1. So whenever we are talking about square root of 16, we take 2 into 2. So this will be our square root. So square root of 16 is 4. So whenever we have a number, we get its prime factors and we count its pair as 1, and this is how we get the square root of a number using prime factorization method. Moving to the next part, we have cubic numbers. Likewise, we have studied that square numbers are closely related with area of squares. In the same way, cubic numbers are related to the volume of cubes. Like a cubic number is a number that is multiplied itself 3 times. Like when we multiply 2 cross 2 into 2, we get 8. So 8 is a cubic number. Similarly, when we multiply 3 cross 3 cross 3, we get 27, and 27 is a cubic number. So whenever we multiply a number by itself 3 times, we get a cubic number. And why this is related to the volume of a cube? Because the volume of cube is nothing but the side cube. In the same way, like we were taking area of a square as side square, in the same way we are taking cube as side cube. This is why these two are closely related. Now let's have a look. In this table we have been given some unit lengths and calculation of volume and how these two are related to perfect cube. For example, if we take unit as 5 units, so volume will be 5 into 5 into 5, and it will be 125, which is nothing but 5 cube. Moving to the properties of perfect cubes. Like we have studied different properties for square numbers, now we have different properties for cubic numbers. So let's move to the very first property, which is unit digit rules for cube. So whenever we were dealing with square numbers, we found that certain numbers form a pattern whenever we were taking square of those numbers. For example, when we were taking square of 1, we were getting as unit digit as 1. And when we're taking square of 9, we were getting unit digit at 1. So we can see that number 1 and 9 followed the same pattern in its unit digit whenever we took a square of those numbers. In the same way, if we take cubic of certain numbers, we get to see some pattern between those two numbers. For example, if we take cube of 1, which is 1, we are talking about unit digits. When we take a cube of 2, which is 8, so in this case unit digit is 8. When we take cube of 5, which is 125, so in this case cubic number is 5. So we can see that all these numbers always end with different unit digits. None of the two numbers represent same unit digit whenever we are taking the cube of certain number. But we get to see a pattern that like when we take cube of 2, we get 8, and when we take cube of 2, we get unit digit as 2. In the same way, when we take cube of 3, we get unit digit as 7, and when we take cube of 7, we get unit digit as 3. So there are certain patterns which we get to see here, which will be covering in different properties of cubic numbers. So let's understand our next subtopic, which is odd and even cubic numbers. Likewise, whenever we were taking a square of even on odd numbers, we were getting the same parity. In the same way, when we are taking cube of certain numbers, for example, if we say cube of odd digit, it will always result in odd number, and cube of an even digit, it will always result in an even number. For example, if we take cube of 1, this will be 1, and cube of 2, this will be 8. So cube of any odd digit is always odd, and cube of any even digit is always even. Now let's count the number of zeros whenever we are taking cube of certain number. So in a square, it was getting doubled in every term whenever we were taking a square of a number. In the same way, whenever we take cube of certain numbers, we get to see that its zeros gets tripled in this section. For example, if we see 10, in its cube we have 1000. Like 10 has 1 0 and 1000 has 3 zeros. In the same way, if we look at 100, 100 has 2 zeros. But when we look at the cube of 100, we get to see 10 lakh, which contains 6 zeros. So whenever we are taking cube of a number that contains 0 at the end, we get to see that its number of zeros gets tripled each time whenever we are taking cube of that number. Now let's move to the certain patterns of perfect cubes. Like we have studied the same for square numbers, let's have a look for the cubic number. So the first pattern is whenever we are adding consecutive odd numbers, we get to see a cube pattern. So first, whenever we take 1 can be written as 1 cube. And when we add 3 and 5, we get to see it is 8, and which is 2 cube. Considering later part, we have 7 plus 9 plus 11, which is 27. This is 3 cube. So somehow, when we take consecutive odd numbers and we add them, we get to see a cube number. So for in general, we can say that any cubic number can be expressed as the sum of consecutive odd numbers. Moving to the second pattern, we have an alternative pattern with odd numbers. Like when we take 1, we can write it as 1 cube, and when we take 2 cube, we can write it as 1 plus 7. For 3 cube, we can write it as 1 plus 7 plus 19. For 4 cube, we can write it as 1 plus 7 plus 19 plus 20 plus 37. So this is how we can use cubic numbers and its pattern to write sum of consecutive odd numbers to represent certain patterns. So moving to the next topic, cubes of fractions, decimals and negative numbers. So whenever we take a fraction, we look for its cube. We simply multiply numerator part to its numerator part and denominator part to its denominator part. For example, if we take cube of 2 by 3, what we need to do here is to multiply 2 by 3 thrice to get the cube of the number. So 2 by 3 multiplied with 2 by 3 multiplied with 2 by 3 results in 8 by 27. So cube of 2 by 3 is 8 by 27. In the same way, we followed the same rule for decimals and for negative numbers. There is an interesting part, like for square numbers, whenever we take a negative number, we always get a positive number. For example, if we take square of minus 5, this will be minus 5 into minus 5, which is 25. So there will be positive sign. But in the case of cubic numbers, whenever we take negative number, so cube of any negative number will always be a negative number. So this is the main difference when we take negative numbers for cubes and for squares. So moving to the next topic, we have cube roots. So cube roots is nothing but the inverse property of finding cubes. So for finding cubes, we were multiplying the number thrice. In the same way, for cube roots, we have to look at the number that are being multiplied to get the cubic number. For example, if we say 8, we can write 8 as 2 cross 2 cross 2. So cube root of 8 will be 2. So we have to look at the number that is being multiplied to itself thrice to get the cubic number. So that number will be called a cube root of the number. For example, there is a notation for cubic numbers, like there is a notation for cube root of a particular number, if we have to find the cube root of 8, we have to write it like this. So this is the notation for finding the cube root of a particular number. So let's understand different properties of cube roots and how to find cube root of a particular number. So our first method is finding cube roots by repeated subtraction. So there is a special case sequence which is 1, 7, 19, 37 and 61. So what we need to do here, we need to keep on subtracting its terms in a sequence so that we reach 0 and we get the cube root of the number. So let's understand this method using this example 16. Here we need to find cube root of 125 using repeated subtraction method. So firstly we'll start with subtracting 1. So 125 minus 1 is 124. In the second step we subtract 7. In the third step we subtract 19 and so on. In the last step we subtract 61. So when we subtract 61 we get the difference as 0. This is the point where we stop. Once we get the 0, we count the number of steps we used in the process. That number represents the cube root of the number. So in this case, we used 5 steps. So in the fifth step, we get the number 0. Therefore, the cube root of 125 is 5. So our next method is finding cube roots using prime factorization method. This is the method we were using for finding square roots. So for square roots, we were taking pairs. And in the same way, for cube roots, we have to look for the triplets. For example, if we have 216, and now we take prime factorization of the number, this is 2 cross 2 cross 2, and 3 cross 3 cross 3. Now what we need to do here is we have to look for the triplets. So 2 cross 2 cross 2 represents one triplet and 3 cross 3 cross 3 represents another triplet. So this is how we have complete 2 pairs of triplets. That is why there is no number that is left unpaired. So we can say cube root of 216 is 2 cross 3, which is 6. So basically we have to look for the triplet. Whenever any number that don't have any triplet present in the prime factorization, we say that number cannot be a perfect cube. For example, if we say 16, we can write 16 as 2 cross 2 cross 2 cross 2 cross 2. So we can see there is a triplet and there is a 2 that is left unpaired. So we can say that cube root of 16 is not possible in this case because it has a pair that is left unpaired for its triplet. So let's discuss another method which will be covering under Knowledge of India section, which represents a special formula like Vilyokanam Sutra. So in this sutra, we'll understand how to get cube root of a certain number in a really quick time. So let's go through the example to understand this topic. So in this example, we can see there's a number given to us, which is 17576. So to get the cube root of the number, firstly we need to divide the number in 2 parts. So we have to make sure that we divide the number from the right end. We take the numbers in pair of 3. So we divide the number like this. From the right we take 3 numbers and the rest we keep it as to the left. So we can see there is a number on the rightmost is 576. And for the left part we have 17. So we can see that the unit digit of 576 is 6 and the cube root of unit digit of 6 is always 6. So we can see that cube root will always contain 6 as the unit digit. Now look at the leftmost part, which is 17. Now look for the cube of a number that is less than 17. We can consider as cube of 1 is 1, cube of 2 is 8, cube of 3 is 27. So we can see 27 is going beyond 17. So we will consider number that is below the given number. In this case, it is 8. So we'll consider the number 2 because 2's cube is 8 and which is less than 70. That's why in the leftmost part will be 2. So the cube root of 17576 is 26. So this is how we use this method. Basically, we'll divide the number in two parts and look for the rightmost part and leftmost part. So for the rightmost part, we take the unit digit and look for its cube root, and for the leftmost part, we look for the number whose cube is less than the given number. Once we get the number, we combine these two numbers to get the cube root of the given number. So, students, this is all for today. In this chapter, we studied what are squares, what are square roots, what are cubes and what are cube roots, and what are different methods to get them. So, keep learning, keep practicing. See you in the next class. Thank you.